Okay, we're just about ready to wrap it up here. We have 2 examples left. I am going to model example 5, then I'm going to model example 6. It's up to you, because we don't have too much time left, to pause the video for you to try it on your own as I'm going through, see if you can make connections, make patterns, right? Because I'm going to model these last 2 problems for us, okay? Here this is simplify and expand. So first I'm going to show this work with expansion. This is the entire base, and it's being multiplied 4 times. Right? And you can even break that down even more. Right? 5 times m times m. And you can do that a few times here. This is what that expansion looks like. But then we're going to use our pattern that we noticed, the power to the power rule, to do this a little quicker. Right? 5 times 5 times 5 times 5. That's going to be 5 to the what? That's 5 to the 4th power. 5 times 5 times 5. And then that's going to be 1, 2, 3, 4, 5, 6, 7, 8 amps in my bank account. Oh, see? It's not 8 to the m power. It's m to the 8th power. Amps in my bank account. And my 8 amps, all right? So that's what that looks like right there. And that could be your answer, simplified, beautiful, easy. Using the new method that we learned today, the power to the power, the more efficient method, right? This is 5 to this is m to this is not 5m to the second power. This is 5 to the first power, m to the second power. How could you use the more efficient method we learned today to do this? Yeah, that's right. 4 times 1 to the first power, and then m to the second raised to the 4th power as well. This would still give you 5 to the 4th. 4 times 1 is 4. M to the second, right? M to the 8th. 4 times 2 is 8. It's very similar to distribution, all right? Very, very similar to distribution. Okay? So that's how you can do this right here. Both of these are correct. Now go ahead and see if you can do example 6 on your own, because I'm getting ready to model this one as well. Okay, this is the last example. We just did this one. See if you can try to expand and then simplify using our strategy on the side, okay? So this is, negative 3x to the 3rd. This is my base, and then it's being raised to the 5th power. Oh my goodness. This is why we use that power to the power rule, because we're not going to have all day. Ain't nobody got time for that, to be constantly writing that out, right? And you know that this is negative 3 times x times what? X times x, and then negative. How many times are we doing this? We're doing this 1, 2, 3, 4, 5 times, right? See, I don't even want to write that out as many times as I do, right? So what can we do instead of having to sit here and expand? We can use our new method, right? And this is negative 3 to the 1st right here. And this is x to the 3rd right here, right? And similar to distribution, but you're going to keep it all in the parentheses. Keep it in the family. Keep it in the family here, right? Negative 3 to the 5th power. It's going to be x to the, that's right, you guessed it, to the 15th power. This is completely fine. This right here is completely fine. Because if we did this 5 times, this would have been negative 3 5 times. This would have been 3x's 5 times. 3 groups of 5 is 15, right? That's the new method that we learned today, right? So we talked about an efficient way to use a power to a power. And you're going to fill in some vocabulary just to stamp that idea. You might have one more problem. And then I'll see you during live block. Thank you so much. Power to the power rule. What do you do when you have a power to a power? You multiply your exponents, okay? Thank you for watching. Thank you for listening. And I will see you later.